All right, so homework 9, starting with outcomes and event probability. Basically, they were nice and they gave you all the possible outcomes of flipping a coin 3 times. If I flip my coin, I might get a heads on the first time, might get a tails on the second time, might get a tails on the third time, however it might be. So a coin is tossed 3 times. An outcome is represented by a string of the sort HTT, means a head on the first toss followed by 2 tails. The 8 outcomes are listed in the table below. Note that each outcome has the same probability. So they want us, for each of the 3 outcomes in the table, check the outcomes that are contained in the event, then in the last column enter the probability of the event. So on the first one it says no heads on the first 2 tosses. So, no heads on the first 2 tosses. Well, this one has a head on the first one, this one has a head on the first one, this one has a head on the second one, this one I have a tail and a tail, so that would not have heads on the first 2 tosses. Then I've got a head and a head, then I've got a tail and a tail again, head, 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 and then I have a tail and a head. So in that list there are only 2 of them that don't have a head on the first 2 tosses. My probability then is going to be 2 out of 8, which we would just reduce down to 1/4. The probability of getting no heads on my first 2 tosses would be 1/4. So on the second one, we want a tail on both the first and the last tosses. So which one shows me tails on the first and the last? Here, yeah. Which ones of those things would have a tail on both the first and the last toss?
The fourth one.
The tail has one on the first and the last.
And the last.
And the last one. Those are the only 2 that have tails on both the first and the last. So again, we've got 2 out of the 8. So 2 out of 8 reduces down to 1/4 for my probability. And then the third one there, a tail on the first toss. Which one show me a tail on the first toss?
The third, fourth.
Third one, the fourth one, the sixth one, and the last one. They all have a tail on the first toss, which means we have 4 out of 8. 4 out of 8 reduces down to 1/2. So my probability of getting a tail on my first toss, 1/2. All right, those ones aren't so bad. So on the second one, suppose that the gender of 3 children of a family are soon to be revealed. An outcome is represented by the string of the sort. GBB means the oldest child is a girl, the second oldest is a boy, and the youngest is a boy. The 8 outcomes are listed in the table below. Note that each outcome has the same probability. And again, we're going to check off which ones are true and then figure out what the probability is. So first one wants to know exactly 1 girl. The last 3. That one has 1 girl, that one has 1 girl, that one has 1 girl. So the probability would be 3/8. Can't simplify that. So 3/8 is my probability. Event 2. 2 or more girls.
The first 4.
The first 4. We have 2 girls, 2 girls, 2 girls, and then we have 3 girls. So that one would be 4/8 or 1/2. Exactly. 1/2 would be my answer in best form. And then the last one, the boy on the first or the second birth, or both. So we can have a boy on the first one, a boy on the second one only, or a boy in both the first and the second one.
So the second one.
Second one.
The third one.
Third one.
Fifth one. Sixth one.
Fifth one has. Fifth one, sixth one.
Seventh one.
Seventh one.
And eighth one.
And eighth one. So we got a lot of them there. We have
6/8.
6/8, which reduces down
3/4.
to 3/4. Exactly. And back to the coin tossing one, they like to use that. A coin is tossed 3 times. My outcome is represented. HTT means a head on the first, followed by 2 tails. My 8 outcomes are listed. First one we want to do exactly 1 tail.
So the first one and the fifth one.
First one and the fifth one and the sixth one also, right?
Oh yeah.
Sixth one only has 1 tail. So my probability there is
3/8.
3/8. A tail on each of the first 2 tosses. So we got to start with a T and a T. Which ones start with 2 T's?
Second and last one.
The second one and the last one. So my probability 2/8 or 1/4, right? And then the last one, more tails than heads.
Second and third.
Second and the third.
And the last two.
And the last 2. And so we would have 4/8, which is 1/2 then. All right. So now they weren't quite as nice. We are going to talk about rolling a die, and actually we're going to roll 2 of them. An ordinary fair die is a cube with numbers 1 through 6 on each of the sides. Imagine that such a die is rolled twice in succession. That leaves the face values of the 2 rolls are added together. The sum is recorded as an outcome of a single trial of a random experiment. So what they think you're doing here is first of all figuring out all your possible outcomes. If I roll my dice and I get a 1 and a 1, my sum is going to be 2, right? If I roll my dice, if I get a 1 and a 2, or a 2 and then a 1, my sum is going to be 3. So how could I get 4? A 1 and a 3, 3 and a 1, and 2 and 2. That gives me a sum of 4. Those are all my ways I could get 4. How about 5? 1 and 4, 2 and 3, 4 and 1, 3 and 2. Did we get them all? 1, 2, 3, 4. Yep, that's what I have listed. 4 of them. So, oops. 5. My sum was 5. I had 4 ways to get 5, but my sum was 5. How was 6?
5 and
1 and 5, 5 and 1,
1. 3 and 3.
3 and 3,
4 and 2. 2 and 4.
4 and 2, and 2 and 4. Those are all my ways to get 6. Okay, 7.
5 and 2. 2 and 5.
5 and 2, 2 and 5,
6 and 1.
6 and 1, 1 and 6,
3 and 4. 4 and 3.
3 and 4, 4 and 3. Those are all my ways of getting 7. 8.
6 and 2.
6.
3 and 5. 5 and 3. 4 and 4. 7 and 1. 1 and 7.
Can we get a 7 on our dice?
Oh,
Nope.
no.
9.
3 and 6. 4 and 5. 5 and 4.
10.
5 and 5. 6 and 4. 4 and 6.
11,
6 and 5, 5 and 6.
and 12.
6 and 6.
There's all our possible ways, right? If we got them all listed. So now we can answer all our questions. It says, first of all, the sum is greater than 6. So if my sum is going to be greater than 6, it means I'm going to get 7 through 12, right? I have to figure out how many ways I can get a sum of 7 to 12. How many ways did I have altogether? We probably, I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36 altogether. So we know it's going to be out of 36. We want to find the sum is greater than 6, so we want to add up all the ones to up to 12. If you just count them up, how many do you get there?
Well, from 6 or
Greater than 6, so we're not
So
including the
just
6,
the
we're
same.
just going 7 and higher. Yep. 21, that's what I got. 21 out of 36. They are going to change these to a decimal. It says round your answer to 2 decimal places. That gives me a clue that they're using the decimal instead of the fraction. So if you take 21 and divide it by 36, you get
5.8.
0.58.
Yeah.
0.58. In other words, a 58% chance that you're going to get 7 or higher. Now we want to find event B. Event B says the sum is not divisible by 4. So we can't use 4, 8, or 12, right? I want everything but 4, 8, and 12. Now one thing you could do is add up the 4, the 8, and the 12 and then subtract from 36 because you know your total is 36 if that's easier than counting all the ones that are not 4. Not divisible by 4. So if we do the ones that are divisible by 4, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If I take 36 minus 9,
It's going to be 0.25.
it's going to be 27, right? 27 out of 36. Oh, you did. Okay, you got to subtract first. I think you didn't subtract yet.
Oh, 0.75.
So 0.75. Okay, so I counted up the ones that were divisible by 4 because there were less on my list, subtracted from 36. So if 9 are divisible by 4, 27 are not divisible by 4, and then I can do my fraction. 27 out of 36. Number 5. Number 5. Again, we're just doing the same dice problem. This time we want to find a sum that is greater than 7. So the 8, 9, 10, 11, and 12. How many do we have in the 8, 9, 10, 11, and 12 categories?
Fifteen?
15 out of 36, which comes up to be,
0.42. Do you want us to round or not?
yeah, round to the 2 decimal places it says. So 0.42, yep. All these ones here will say at least 2 decimal places. The sum is divisible by 3 or 4 or both. So anything that's divisible by 3 or 4 or both. It's divisible by 3. So 3, 4, 6, 8, 9, 12. I think all those are divisible by 3, 4, or both.
26. Is it 20?
20, that's what I got. 20 out of 36 is what I came up with.
0.56.
0.56. All right. Now I hope you have that written down because I got to move the board to get to number 6. By the way, if you go to Linda's notes, you'll have a nice little table of all of those. You might have them on the Alex notes. I can't remember. But for sure on my notes, I put it on there. All right. So on this one, we want to have a sum that is greater than 9. So 10, 11, or 12. How many ways can we get 10, 11, or 12? 6 out of 36. So 6 divided by 36. I don't know why I wrote a 2. 6 over 36 would be
1.7.
0.17.
0.17.
0.17. And then the sum is divisible by exactly 5. So 5 and 10, probably the only 2 ways to be divisible by 5. 7 out of 36, which would be 0.19, 19%. All right. Probabilities of draws with replacement. So once I draw it out, I'm going to put it back in, and the chance of drawing it again would be the same. So it says an urn contains 8 black and 9 green balls. 4 balls are randomly selected from the urn in succession with replacement. That is, after each draw, the selected ball will return to the urn. What is the probability that all 4 balls drawn from the urn are green? What we're going to do is the probability of each one separately and then multiply those probabilities together. So, I'm going to draw 4 balls from the urn. I want the probability that all of them are green. If I'm going to do my first draw, I'm going to have 9 green balls out of 17 of them all together. So the chance of getting a green one is 9 out of 17. Since I'm going to replace my ball once I draw it out, my probability of getting a green one on the second one is still going to be the same thing. 9 out of 17. Again, I'm going to replace my ball on the third one, so to get the green one would be the same thing, and the last one would be the same thing. So basically, I'm going to just have 9/17 to the 4th power because all 4 of them would give us the same probability. They are going to round these off to 3 decimal places. So you can either do 9/17 times 9/17 times 9/17 times 9/17, or take 9/17 to the 4th power. Nope, I don't think it's 1 point something.
Oh.
If you are doing your exponent, you may need the parentheses around your fraction. We're going to 3 decimal places. So we're going to have point
0.079.
There we go. 0.079 is where that would round off to 3 decimal places. Okay. Number 8. We have a fair die that's rolled 5 times. What is the probability of having no 1s and no 2s? So what's the probability of not having a 1 or a 2 on my dice?
2 are 1/3.
that's having a 1 or a 2. We want to have not having a 1 or a 2.
4 out of 6.
4 out of 6. You could reduce that down if you wanted to. We're going to roll the dice 5 times. So again, since I'm going to get the same chance all 5 times, I can just take it to the 5th power. Or 4, 6 times 4, 6 times 4, 6. If you want to reduce it down to 2/3, it'd be the same thing. And again, we're rounding it off to 3 decimal places.
0.132.
0.132, okay. A fair dice is rolled 5 times again. What is the probability that a 6 is obtained on at least one of the that a 6 is obtained on at least one of the rolls? So on this one, because it would be hard to figure out the at least one of the rolls, what we want to do is figure out if it's not going to be a 6, and then we're going to take 1 minus that value. 1 would be 100% chance, and so if we do 1 minus, so if I'm not going to get a 6 on my roll, I have a 5, 6 chance of not getting a 6, right? So I would have 5, 6 to the 5th power. I'm going to do 1 minus that answer since I actually want to get a 6 on one of my rolls.
.598.
0.598, yep, is what you should come up with. So on this one where they say at least one of the rolls, what you want to do really is figure out if it's not on any of the rolls, because it's be easier to do. And then you take 1 minus that answer. All right, the next ones we are now not going to replace, so our values won't be exactly the same every time. And so, a history class is comprised of 10 females and 3 males. The instructor of the class randomly chooses 5 students from the class for an oral exam. What is the probability that 3 female students and 2 male students will be selected? So, we are going to use combinations here when we figure this out because the order doesn't matter. And so first of all, we're going to figure out the combination for the females. We have 10 females, and we want to find the probability of that 3 of them are selected. So we're going to do a combination of 10, choosing 3 at a time. Remember how to put that in your calculator. $120, okay. I'm just going to put it beside that. Now we are going to multiply that by the boys. For the boys, we have 3 male students and we want to choose 2 of them. So we have a combination of 3 choosing 2. If I do that, I'm going to just get do 3 choosing 2.
3.
I'm going to get 3 because the 2 factorial would cancel out on the bottom. That means on the top of my fraction, I have 120 times 3, which would be 360 possible ways. Now on the bottom of my fraction, I have to have the total number of outcomes. So on the bottom fraction, we have a total of 13 students to choose from, and we're picking 3 plus 2, so 5 altogether.
1,287.
1,287. Again, we are going to write our answer to 3 decimal places. So now we're going to take our 360 divided by our 1,287 and then round it off to 3 decimal places.
2.280.
Yep, and then we'll put the 0 there just to show that they went to 3 places. So we found the combination of the first event times the combination of the second event, and we on the bottom did the combination of the total that we had. So on number 11, we have an urn that contains 10 orange balls and 9 red balls. If Tim chooses 15 balls at random from the urn, what is the probability he will select 9 orange balls and 6 red balls? So if I'm going to get 9 orange balls, I'm going to do a combination of
Probably
10 total orange balls, and I want to get 9.
Yeah.
Yep, I want to get 9 of them. And if I do that, I get
10.
10. I'm going to multiply it by my probability for my red. For my red, I'm going to do a combination of 9 red balls, and I'm going to take 6 at a time, so I would end up with 84. 10 times 84 gives me 840 on the top, right? On the bottom, I want my total combination. The total amount of balls I had was
10 or 15.
19,
Or,
and I'm going to take 15 of them, right? I had 19 balls altogether. I'm going to choose 15 of them. So if I do that on my calculator,
$3,876.
3,876. So then we're going to take our 840 divided by our 3,876 and round it off to 3 decimal places.
0.217.
Exactly, 0.217. Number 12, same kind of thing there. A history class is comprised of 3 females and 5 males. If the instructor of the class randomly chooses 6 students from the class for an oral exam, what is the probability that 2 female students and 4 male students will be selected? So if we start with our female students, we would have
Wait.
a combination of how many total females?
2.
The total females?
Oh,
3, and we're going to choose 2 of them. There's 3 altogether, we're going to pick 2 of them, which would give me 3. And then for our males, we're going to have a combination of 5, and we're selecting 4, which gives me 5. 3 times 5 means we have 15 total ways of getting our 2 females and our 4 males. Now we have to do the total of the group altogether. So we're going to have a combination of how many students do we have altogether? 8, and we're going to choose 6 of them, right?
Twenty-eight.
28. And so 15 divided by 28 would give us what to 3 decimal places?
0.536.
0.536, exactly. All right. Probability of independent events. basically what we're going to do again is find the probability of a fraction of each event separately and then multiply those two fractions together. Just like we did before, but now we got bigger numbers. At a local college, 297 of the male students are smokers. 693 are non-smokers. Of the female students, 330 are smokers and 670 are non-smokers. A male and a female student from the college are randomly selected for a survey. What is the probability that both are smokers? So for the males, how many were smokers? 297. Out of a total, how many total males do we have? If 297 are smokers and 693 are not, if I add those together, how many total males are there? 990. Now we're going to do the females. So for the females, how many are smokers?
330.
330, and then we need the total number of female students, 1,000. All right, so now we need to multiply those two things together. And again, where are we rounding this to? Oh, it says do not round your answers. Do not round your answer.
Is it 0.99?
So you get 0.099? Or did you get 0.99?
I got 0.99.
Try punching it in again. You must have left a zero off somewhere.
Oh yeah, I did. Sorry.
Okay. I got 0.099. Everybody getting that?
I put in 100 instead of 1,000.
So if you wanted to put that in all together, following your order of operations, you could take this times this, but then when you divided, you'd want to take it divided by parentheses this times this, because I have to put that together. Okay, I better move the board up for number 14. Ooh. Number 14, a spinner has 20 equally sized sections, 2 of which are blue and 18 which are green. The spinner is spun at the same time. A fair coin is tossed. What is the probability the spinner lands on green and the coin tosses heads? So, first of all, we want to figure out the probability that the spinner lands on green.
Eighteen.
18 out of 20, right? That's my probability it's going to land on green. I have 18 chances out of 20. For my dice, what's the probability that I'm going to toss a head? 1 out of 2, right? You either have a head or a tail. You got 1 chance out of 2. I'm going to then just multiply my probabilities together. And do not round my answer. Should come out somewhat nice.
0.45.
0.45, yep. Here, that one wouldn't be too bad to multiply 18 over 40, and then I could divide, or whichever way you did that. Number 15. A student ran out of time on a multiple choice exam and randomly guesses the answers for 2 problems. Each problem had 4 answer choices, A, B, C, or D. Only 1 correct answer. What is the probability that she answered neither of the problems correctly? So, if I didn't answer them correctly, that means I answered them incorrectly. What's the probability I'm going to get the question wrong? 3/4. I have 2 questions, and the probability for each of them is going to be the same, right? So 3/4 times 3/4 is how I would find that.
Is it 0.5625?
Yep. You should get 0.5625 when you multiply that out. All right, this one's a little crazier. It says, a particular die has the following properties. On any roll, the probability of rolling either a 3, a 5, or a 1 is 1/2, just like it would be with an ordinary die. Moreover, the probability of rolling a 1, 6, or 4 is, again, 1/2. However, the probability of rolling a 1 is 7/16, not 1/6, as you would expect. From what we know about this peculiar die, what's the probability of rolling either a 3, a 5, or a 2? So if I look at my choices here, this one has a 3, 5, or a 1. This one has a 1, 6, or a 4. Notice that those are the total opposites of these three right here. So my probability of getting a 3, 5, or a 2 is 1 minus the probability of getting my 1, 6, or my 4. Well, if my probability of getting a 1, 6, or a 4 is 1/2, then I'm going to have 1 minus 1/2, and my answer is going to be 1/2 then. So if I'm looking for it not to be that, I'm going to do 1 minus that other probability. Now the next one wants the probability of just getting a 3 or a 5. I know that if I'm going to get a 3, 5, or a 1, my probability is 1/2. What I want to do is subtract the probability of the 1, which is 7/16 then. So I know that 3, 5, or 1 gives me a probability of 1/2. I'm going to subtract the probability of just getting a 1, 7/16. And so if you take 1/2 minus 7/16, hopefully you get 1/16, right? 1/2 is the same thing as 8/16, and 8/16 minus 7/16 would be 1/16. Okay, so number 17. Our peculiar die has the following properties. On any roll, the probability of getting a 2, a 3, or a 1 is 1/2. Moreover, the probability of getting a 1, a 5, or a 6 is again 1/2. However, the probability of rolling a 1 is 7/16, not the 1/6 we would expect. So we want to find the probability of rolling anything but a 1. If I want to find anything but a 1, I can take 1 minus the probability of getting a 1, right? I'm not going to get a 1, so I'm going to do 1 minus the probability of getting a 1. 1 minus 7/16 then is going to be my problem. And if I take 1 minus 7/16, I get 9/16, right? 1 would be 16/16. 16 minus 7 gives me 9/16. The next one, we want the probability of rolling just a 4. Probability of rolling a 4. I don't have a 4 on any of my lists. So, what I want to figure out is the probability of doing all but the 4. Which means, again, I'm going to do 1 minus something. So, if I'm going to do all but the 4, I know that the probability of getting a 2, 3, or a 1 is 1/2, right? The probability of getting a 1, a 5, or a 6 is also 1/2. But notice here, I've got the 1 in here twice. So I have to subtract off that probability of just getting a 1. And so my problem's going to look like that. If I'm going to get all but the 4, I'm going to have every number except for the 4. And since the 1 repeated, I've got to subtract it off my problem. So you're going to do 1 minus, and in parentheses, 1/2 plus 1/2 minus 7/16. And you get?
4, 3, 7, 9.
I don't think so.
1.
Nope, I shouldn't get 1. If I look at this, 1/2 plus 1/2 is 1. So I'm going to have 1 minus 1, which would cancel out, minus a negative, going to make that a positive. I should end up with 7/16 when I'm done. So on your calculator, you should put 1 minus parentheses, and then do all that in your parentheses, close your parentheses. Try it again. See if you get 7/16. Or you could do the 1/2 plus the 1/2 minus the 17th, and then 7/16, then 1 minus your answer. Are you getting 7/16? Yes, no, maybe? Yep. So, put 1 minus, parenthesis, and then you're going to do 1 divided by 2 for 1/2, plus 1/2, minus, or 7/16. Those are parentheses, and what do we come up with? Oh, it gives you the decimal. On this, to change it from a decimal to a fraction, you hit the math button, and then number 1 for fraction, and enter. There it is. Ah, I can see why you're confused. The calculator was giving you a decimal. Alrighty. Number 18. Again, we have our peculiar die. Peculiar die has the following properties on any roll. The probability of getting a 6, a 2, or a 1 is 1/2. Moreover, the probability of getting a 1, a 4, or a 5 is 1/2. This time my probability of getting a 1 is 1/4, not the 1/6 as we would expect. So we want to first find the probability of getting a 3, a 4, or a 5. If I'm going to get a 3, a 4, or a 5, which one of those can I use? I'm going to use this first one and say that it's not the first one, right? If I don't get a 6, 2, or a 1, that means I've got a 3, a 4, or a 5. So I'm going to do 1 minus that probability of getting our 6, 2, or a 1. Well, the probability of getting a 6, 2, or a 1 was 1/2. And so 1 minus 1/2 would give us a 1/2. So if the numbers are on my list are exactly opposites of one of those choices up there, I can do 1 minus that. It's not those numbers. What is the probability of rolling neither a 6 nor a 2? So if I want neither a 6 nor a 2, since this is 6, 2, and 1, what could I do? I can take my probability of getting a 6, a 2, or a 1 and subtract the probability of getting the 1, right? Because I don't want the 1 there. I want just the 6 or the 2. So probability of getting the 1. Now again, this says neither the 6 nor the 2. This is going to give me the probability of getting a 6 or a 2. So I'm going to take 1 minus that answer when I'm done. So probability of getting a 6, 2, or a 1 was 1/2. The probability of getting a 1 was a 1/4. And so I'm going to do 1 minus the 1/2 minus 1/4. 1/2 minus 1/4 is a 1/4. 1 minus 1/4 should hopefully be 3/4, right? So here we wanted neither the 6 or the 2, so we found the probability here of getting the 6 or the 2, and then again 1 minus that since we wanted neither of those. Those ones will probably take you some practice, I'm guessing. All right, number 19 here. It says a sample of 412 people is selected. The people sampled are classified according to their places of residence and the highest educational degree they have earned. The results are given in the contingency table below. So, in the urban area, yep, I can talk. In the urban area, 40 didn't have a college degree, 30 had 2-year degrees, 17 had 4-year degrees, 42 had advanced degrees, and so forth. We want to find what the relative frequency of people in the sample whose place of residence is suburban and whose highest degree is 2 years. So both of those two things have to be true. How many people are from the suburban area and have 2-year degrees? Looking at my table. 36 of them. 36 out of how many total people were surveyed? 412. We want to, again, round our answer to 2 decimal places, so we're just going to divide there. 36 divided by 412. To 2 decimal places, so 0.09 is where they're going to round that off to, 0.09. Okay? Number 20, we have a sample of 288 adults. The adults are classified according to their voter registration status and their preferred source of current events information. The results are given in my table below here. So for my registered voters, 45 like to get their information from TV, 34 from newspaper, 47 from radio, 26 from internet sites. Among the adults in the sample who prefer to obtain their information through television, what is the relative frequency of those who are not registered to vote? So this time we're only worried about the ones through television. Which ones are not registered to vote? How many people there? 50, and instead of being out of the total surveyed, this time the total is out of only those that were through television. How many people like to get their source of information through television? 95. So 50 out of 95. So let's see the difference in that one. They say we're only going to look at the through television, that's our total. 50 out of the 95 then to 2 decimal places. 0.53 then, 0.53. Number 21, a survey of a sample of 297 people is conducted. The survey's respondents are classified according to their political affiliation and their opinion on a bill. The results are given in the contingency table below. What is the relative frequency of respondents who are in favor of the bill? So, what is the total amount of people that are in favor of the bill there? 92. All of these people are in favor. 92 out of 297 total. And so then I'm going to do it to 2 decimal places.
0.30 or 310.
0.31. To 2 decimal places, right? 0.31. All right. Number 22, suppose that 40% of the women who gave birth at a certain hospital last year were over 30 years old, and that 37% were unmarried. If 13% of the women were both unmarried and over 30, what is the probability that a woman who gave birth at the hospital was over 30 or unmarried or both? So what we're going to do on these ones is you're going to find the probability of the first plus the probability of the second, and then you're going to subtract the probability that both occurred because you have those extra ones that overlapped. And so, for over 30, 40% as a decimal would be 0.40. Unmarried, 37% were unmarried. Then what we're going to do is subtract off where they overlap. They overlap with 13% of them doing both of them, right? And then we're just going to do our adding and subtracting. .64. 23, suppose that 52% of all the adults in a certain community are obese and that 48% suffer from diabetes. If 75% of the adults in the community are obese, are obese or suffer from diabetes or both, what is the probability that a randomly chosen adult in this community is both obese and suffering from diabetes? Same kind of thing going to happen here. We're going to find the probabilities of each of them separately, then subtract off the ones where they're that one or the other one, and that will give us which ones are both. So my obese is 0.52 plus my diabetes people, 0.48. I'm going to subtract off the ones that are in the or category, and that will give me the answer to how many have both. 0.25. You got 0.25. And the last one, same kind of thing. A retail shop accepts only cash or checks. Suppose that 42% of its customers carry cash, 41% carry checks, 35% carry both. What is the probability that they carry cash or checks or both? So what are we going to do to solve this? Just because I don't know where that cut off, I'll just go back to the beginning of this one. A retail shop accepts only cash, checks, or checks. Suppose that 42% of its customers carry cash, 41% carry checks, and 35% carry both cash and checks. What's the probability that a randomly chosen customer at the shop is carrying cash or checks or both? We took the probability of the customers carrying cash, 42%, plus the probability of those carrying checks, 41%, and subtracted off the 35% that carry both, and our answer was
0.48.
0.48. Okay.